Okay, there's a ton of stuff on this image, and all I want to do is I want to go through parts of it. I don't want to talk about everything on it, but I want to go through parts, and I want to describe to you what I feel is important for the waves, one of the waves quizzes. So this is the electromagnetic spectrum. These waves are the ones that can go through a vacuum. They can go through outer space, and a lot of them can come through the atmosphere, or some of them can come through the atmosphere and get to us here on Earth, like visible light and radio waves. But thankfully, some of the more dangerous ones, like X-rays, gamma rays, and ultraviolet, a lot of those get blocked by our atmosphere. But anyway, the big picture here, I really want to focus on three things. I want to focus on the wavelength, how long these waves are, the frequency or hertz, how many waves pass by per second, and how much energy any wave type has. So those are the big ones that I want to talk about. So let's start with the most dangerous one. Let's start with gamma rays. This part of the spectrum down here. Gamma rays have a very short wavelength and a very high frequency. These two things coupled together means they have a very high energy. Out of all the EM waves, these are the ones that are the most dangerous. Okay, just to throw some numbers at you, look at this. Right here, the wavelength, 10 to the negative 12. That's like a thousandth of a billionth of a meter. That's a very, very short wave. And then look at the frequency, 10 to the 20, 10 to the 21st. What's that? That's like billion, thousand, billion waves per second. So that's a lot of waves going by. So gamma rays have the most energy out of all the different types of EM waves. Next, then, the next type is X-rays. X-rays, they also have a very short wavelength, not as short as gamma, but they also have a very high frequency and therefore a pretty high energy. So X-rays, as you already know, will blast right through your body. We use them to take pictures of your bones. What's going on there is the X-rays travel right through your soft tissues, and then they get absorbed or maybe reflected by your bones. So only the rays that went through your soft tissues make it to the film, and then that's how we get the pictures of your bones. So X-rays are also dangerous to be around if you're around enough of them. The scientists who first started working with X-rays years ago, many of them lost their arms and then their lives because they got cancer from being exposed to the X-rays too much. Next, let's go. I don't know if I need this little chart up here for a little while, but let's keep going toward the left on this. The next type of wave is ultraviolet. Ultraviolet, you know, causes suntans and sunburns. Not good for you. Too much ultraviolet also causes cancer. So everything from ultraviolet to the right, these guys all have pretty short wavelengths, pretty high frequencies, and pretty high energies. As a matter of fact, all three of these are called ionizing EM waves because they can take atoms and rip electrons off of them and make chemical changes happen. So that's what makes them so dangerous. Okay, so the next waves over, just longer than ultraviolet, is this tiny little sliver right in here. These are the ones that we humans can see, the visible spectrum, or the visible electromagnetic waves. And they run from the longest waves we can see are red at 700 nanometers, or billionths of a meter. And the shortest waves that we can see are violet, or 440 billionths of a meter. So that sounds pretty short. It is. It's kind of hard to conceive of it. But those are the waves that our human eye is tuned into. So it's kind of weird to think that out of this whole spectrum, you know, from 1,000 meters down to, billionths and billionths of a meter, our eyes, we can only see this tiny little sliver of the spectrum, the visible portion of the spectrum. Keep going longer. The next longest wave past red is called infrared. And that is what military vision uses, or your remote controls. A lot of those use infrared. Infrared waves, you can feel those as heat. Warm objects tend to give off, a lot of infrared waves. They are not ionizing. So now that we're to the left of ultraviolet, now we're getting into waves that are longer, with lower frequencies and less energy. These ones are safer to be around. Okay, so what's next after infrared? The people that I stole this image from, they put terahertz in here. I don't know why they did that, but anyway, radio and microwave, they are next. Some people consider microwave to be its own section, and then other people consider microwave to be part of the radio spectrum. So we're just going to we're going to say that this is all just one big batch. So what kind of stuff is going on out here? Well, these waves are longer, lower frequency, and lower energy. As a matter of fact, we are awash in radio waves. We have been our whole life. If you turn on a radio right now in this room, you'll be able to hear radio stations because there are radio waves bouncing around this room. They are not as dangerous. Shorter radio waves, we can use those to cook our food or to send internet signals through your house, or we bounce them off airplanes, or we use them in our cell phones. That's how they talk to the cell towers. And then you've got really long waves, AM and FM radio. These waves are, like I mentioned earlier, 1,000 meters long or longer. There's really no limit to this scale. It could keep going. But so this is the EM spectrum, and I just wanted you to have an introduction to it because there are some questions about it on that mastery quiz.